All right, so we're going to combine everything we've learned in Newton to solve this problem here. We're going to solve for the acceleration of the system. So there's a lot of parts that we have to look into in order to solve. First thing we have to do is we have to find f sub g sub x for our small box. So here, if we were to draw our small box as the little diagram, the force of gravity is all the way down. So this is just its weight, mg. This is f sub g sub y, which is going to equal the normal force. And here I have f sub g sub x. F sub g sub y. We're going to come back to him later. So first, f sub g sub x. Now, this guy right here is going to be a component of this. So whatever this value is its weight. So it's its mass of 3 kilograms times gravity. So 3 kilograms times gravity is 10 meters per second squared. And this angle here is 30 degrees. So I'm looking for the opposite, so I'm going to use sine of 30. And anytime it's the sine of 30, it's 0.5. So 3 times 10 times 0.5 is going to be 15 newtons. So the force of gravity in the x that's moving my 3 kilogram block down the incline is 15 newtons. Well, on the other side of the pulley, there's our 7 kilogram mass. And if I find out the force that's applied on him, since it's just straight down, it's just mg. So 7 kilograms times 10 meters per second squared is 70 newtons. So 15 newtons is pulling one way, 70 newtons is pulling the other way. So if I were to not have any friction at all, the net force would be the difference between the two. But since we have friction, we have to include it in this problem. So the next step is to find the friction force. I know which way it's going, so now I can solve for the friction force. The friction force is equal to mu times the normal force. And f sub g sub y is equal to the normal force since I'm not accelerating in the y plane. Remember, we tilt our axes when we solve this problem. So the normal force, F sub n, is always equal to the mass of the object. So mg, mass, gravity, times the cosine of theta. So 3 kilograms times 10 meters per second squared times the cosine of 30 degrees. 0.866 times 30 is going to give us a value somewhere in the neighborhood of 25.98. So we'll just call it 26 newtons. All right, so I have the normal force. Now, just swoop past him. We got to solve for the friction force. Friction force is equal to mu. Let's give this guy a mu value of 0.3. It's just a coefficient of kinetic friction because the block will be moving. So we'll say 0.3 is my mu value times 26 newtons. Gives us a friction force of 5.2 newtons. All right, we're making our way. I have a friction force, I have the force of gravity in the x, and then I have the force in the other side. All right, I want to solve for the net force. So let's put all the forces acting in one direction minus the forces acting in the other direction. So we're going to start out with our largest force. And our largest force is the 70 newtons. He's just pulling it straight down. So 70 newtons is going to be moving this whole system like that, clockwise to the right, we can say. And then what are my forces in the opposite direction of motion? Well, the force of gravity in the x that we already solved for over here, 15 newtons, is doing that. And friction is always going to be subtracted from your net force. So we can always subtract friction's 5.2 newtons. So when we do all that math, we get a net force of 49.8 newtons. All right, we're almost there. My net force is 49.8 newtons. To solve for acceleration, it's just net force divided by total mass. So 49.8 divided by 7 plus 3, 10 kilograms, is going to be an acceleration of 4.98 meters per second squared. Boom. And there's our answer. And that is all of Newton all together in one problem.